So let's look at B, right? Determine the average frictional force exerted by the ground on the bar. So go back here. Notice that it pushes this whole thing in 75 centimeters, like 0.75 meters, right? And the answer for this was 5 meters per second, right? So in this problem here, we've got the bar and this thing moving downward at 5 meters per second, right? And it stops in a distance of 0.75 meters, right? So what I'm going to do with this thing is I'm actually going to, there's a couple ways to do this, okay? You could say that this thing has potential energy and it's got kinetic energy, right? And then that turns into force times distance. So that's probably the best way to do this, okay? The force is what you're trying to find. The distance is going to be your 0.75 meters, right? The mass here is what, 2,400 kilograms, right? The same with this guy, right? Our change in height, don't forget that it also has potential energy. I got this wrong. So 0.75 meters, right? And then we know that this is our 5 meters per second, right? Okay. And then the other way to do this actually is to, we actually could figure out the deceleration. So suvat this, right? Right, suvat this, and the displacement is what, negative 0.75, initial velocity is negative 5, final velocity is 0. Find this acceleration, and then set up a situation like this where you've got, all 2,400 kilograms, right? It's accelerating up. There's an upward force, right? There's a downward force. It's the force of gravity, right? And you'll end up with force minus mg is equal to m times a, right? And then this is the acceleration you got. This will be a positive acceleration, some positive number, right? So there's two ways to do this. I would use energy, but you can use suvat and F equals ma. Okay, there you go.